A new wastewater treatment plant, which brings together the wastewater treatment of Turku and its neighboring municipalities, was launched in 2008 in Kakkolanmäki, Turku. The wastewater enters the treatment plant along two pipelines. The influent pumps on floor 0 of the plant continuously pump up the wastewater to the beginning of the treatment process. During one day, about 90,000 cubic meters of wastewater flows through Kakkolanmäki wastewater treatment plant, which is 3,800 cubic meters per hour. The amount of wastewater is expected to increase to a maximum of 4,000 cubic meters per hour by the year 2050. The purification requirements for wastewater are set for suspended solids, phosphorus and nitrogen, as well as biochemical and chemical oxygen demand. The requirements must also be met in possible bypass discharges, overflows, and exceptional situations. For nitrogen, the requirement is calculated on an annual basis, and for the other substances, requirements are calculated quarterly. The coarse solid matter is separated from the wastewater by 4 coarse screens with a 10 mm grill width. The solid particles caught by the screens are directed to a screening floor. The wastewater sludge collected on floor 0 of the treatment plant is dried and stored. Approximately 5 tank truckers per day carry dried sludge for post-treatment. After post-treatment, the sludge is utilized as fertilizer and district heating. After the coarse screening, ferrous sulfate is added to the wastewater in the dosage tank in order to precipitate dissolved phosphorus. The addition of ferrous sulfate also facilitates the sedimentation of solid matter on the bottom of the tank in the primary sedimentation phase. Wastewater is led into 4 sand separation tanks that separate sand and grease from wastewater. After the separation of sand, the wastewater flows through fine screening where the bar width is only 3 millimeters. After screening and sand removal, part of the wastewater is led to primary sedimentation, while part of it passes directly to a rapid mixing tank. This way, the amount of organic matter increases in the activated sludge process. A higher proportion of organic matter boosts denitrification during the biological process. In the primary sedimentation, the solid matter in the wastewater sinks to the bottom of the tank. The ferrous sulfate added before the coarse screening precipitates the phosphorus. Scrapers in the bottom of the tank push the raw sludge into a sludge pocket. Approximately 50% of the phosphorus can be removed chemically in primary sedimentation. After the screening and the primary sedimentation follows the core of the purifying process, the activated sludge treatment. Oxygen-consuming organic matter, nutrients, nitrogen, and the remaining phosphorus are removed from the wastewater in this phase. If needed, lime can be added into the wastewater before it flows into the aeration tank in order to meet the target levels for pH and alkalinity. When the wastewater arrives in the aeration tank, it is directed through 6 different zones that are divided by partition walls. Half of the zones are oxygenated and half of them are oxygen-free. The biomass in the aeration tank contains microbes and protozoa, the task of which is to consume the soluble nutrients and organic compounds in the wastewater. Denitrification takes place in both aerobic and anaerobic zones. In the latter, microbes convert nitrate into nitrogen gas, which is released into the atmosphere. In aerobic zones, microbes use organic matter and nutrients in the wastewater. The remaining phosphorus is removed along excess sludge. The ammonium entering the aeration tank is reduced to nitrate in the oxygenated zones. In the secondary sedimentation, the biomass sinks to the bottom of the tank from where it is pumped as returned sludge to the beginning of the aeration process for reuse. The biologically purified wastewater continues its way along the channels to sand filtration. In case the maximum hydraulic capacity of the activated sludge treatment is exceeded, for example, due to stormwaters, the excess water is let past the biological process phase into a bypass water processing unit. Bypass water is treated chemically in the ActiFlow unit, where it is precipitated with ferric sulfate and polymer. In the lamella clarifying process, the precipitated sludge mixed with microsand is settled. Microsand is separated for reuse. Before reaching the sand filtration tanks, precipitation chemicals can be added to the wastewater. Thus, the phosphorus removal of the treatment plant can be made even more effective. In filtration, wastewater flows downwards through the sand bed. In the cleansing phase, the flocculated solid matter in the sand layer is removed by a two-stage backwash. Air is blown into the sand bed from below, which separates the matter trapped by the sand. After this, washing water is pumped through the bed from below. This lifts up the separated matter into the water above the filter bed for removal. The wastewater removed in the wash cycle flows first into equalization tanks, from where it is pumped back to pre-sedimentation for a new cycle of the treatment process. After the sand filtration, the purified wastewater is led via the removal channels of the plant into vast effluent pipes with an outlet into the harbor basin of Turku. There, the purified wastewater mixes with seawater. The high-quality nitrogen and phosphorus removal method of the Kokkolanmäki wastewater treatment plant seeks to decrease the eutrophication of waterways. The old and rundown wastewater treatment plants of Turku and its surrounding municipalities were shut down when the treatment of wastewaters was concentrated to the Kokkolanmäki wastewater treatment plant. The Kokkolanmäki wastewater treatment plant collaborates with the local energy company and the sludge processing provider. The wastewater sludge is utilized as efficiently as possible. The Kokkolanmäki wastewater treatment plant reduces emissions into the Baltic Sea with its operations. Its objective is to keep both our unique archipelago and our city environment clean. We bear our responsibility for the protection of our environment together. Only the sun may go down in the Baltic Sea without purification.